Hello again, chemistry students. We're now ready to have our final topic on our chapter on solutions. And so today we're going to focus in on colligative properties. And so there are 4 different types. And so we will be talking about what each of these types are. What we're going to be doing today, we're going to first of all define what is meant by colligative properties. We'll then also discuss individually each of the 4 colligative properties. And then we'll also see how both boiling point elevation and freezing point depression of a solution are determined. So it's a very simple equation. We do have some terms. We'll go ahead and define what these are. And so let's go ahead and get started. Colligative properties. A colligative property is called such because it depends upon the number of solute particles present and not on the identity of the particle. So it doesn't matter what you actually have. So if you look at the word colligative, if you just look at the first part of the word, think about a collection. And so if you guys collect anything, myself, I collect some rare books, I collect retro video games, and so I can count up the number of books or video games I have in my collection, and so colligative properties depend only upon the number of solute particles and not what they actually are. Among the different colligative properties, we have vapor pressure lowering, boiling point elevation, freezing point depression, and osmotic pressure, which, as you can tell, does relate to the process that we've talked about in biology called osmosis. So we are going to talk a little bit about that as well. So we're going to go ahead and look at each of these 4 colligative properties next. All right, let us start with the first one, vapor pressure lowering. If you remember from our last topic when we were looking at gases dissolved in liquids, which then kind of relates back to Henry's law, as solid molecules are added to a solution, the solvent will become less volatile. And so this will then cause a decrease in the vapor pressure. And so the picture over here is showing you, if you have just the solvent alone, this will be the vapor pressure in this measurement. If, however, you add a solute to this, you'll see that the vapor pressure does in fact get lower. And so the reason that it gets smaller is because you have more things interacting within the solution. So there are solute-solvent interactions contribute to this effect. It's sort of like, for example, if you're on a bus and there's nobody else on the bus, it's very easy to get off the bus. If, however, the bus is crowded, your stop comes up, then you're having to kind of push your way through the crowd in order then to step out of the bus. And so it sort of works the same way with vapor pressure. So as the amount of solute goes up, the vapor pressure comes down. And it's because of the solute-solvent interactions. Therefore, the vapor pressure of a solution is lower than that of the pure solvent. And so as you add more and more solvent, it will cause a increased lowering of the vapor pressure. All right. We're going to consider both of these 2 together because they are related. We have boiling point elevation and freezing point depression. So remember, the boiling point is the temperature at which a liquid goes into the gaseous phase, or vice versa. Freezing point is when a solid is being made from a liquid, the temperature at which that happens, or vice versa. The solute-solvent interactions can also cause higher boiling points and lower freezing points than the pure solvent. And so the graph over here, which you will not be responsible for, shows you then, for example, the freezing point here is going to be lower than it would be in just the pure solvent, and the boiling point is going to be higher than it would be in the pure solvent. And so the delta here is a symbol that means a change of. So we're looking at the change in the freezing point, and then we're looking at the change in the boiling point over here. And so I'm going to show you guys 2 very simple equations to help you calculate what the change in either the freezing point temperature or the boiling point temperature is going to be. All right. Although we talked about the fact that in chemistry, molarity is the most common way that we express concentration, when it comes to both boiling point elevation and freezing point depression, we're going to be looking at molality. And so remember, molality is the moles of solute divided by the kilograms of solvent. And so also remember that molality is not dependent upon temperature. And so molarity is, but molality is not. The change in boiling point is proportional to the molality of a solution. So as the molality of a solution increases, so does the change in temperature also increases. We have a constant here, K sub B. The B stands for boiling. The K sub B is the molal boiling point elevation constant, which is a property of the solvent. And so chemistry textbooks or handbooks would have tables of these various molal boiling point elevation constants. So obviously you would not have to memorize this. On the test, when I give you problems for both boiling point elevation and or freezing point depression, I would give you this number. So you would obviously not be able to know that off the top of your head. So I would give you that information. All right. The delta T sub B is added to the normal boiling point of the solvent. And so, again, this is why it's referred to as elevation, because it's increasing the boiling point temperature. So whatever this delta T sub B would be that you would calculate, it's going to cause the boiling point temperature to increase. So you would add that then to the normal boiling point of the solvent. We have a very similar situation when we're looking at freezing point depression. And so we have an almost identical equation. Delta T sub F equals K sub F times molality. And so in this case, as molality goes up, the freezing point temperature should go down. And so we can also see we have constants over here that would be in a table that you'd find in a textbook or a handbook. And so these K sub F is the molal freezing point depression constant of the solvent. And so what this means then is that you would need, once you find out what the change in temperature is, you would subtract that from the normal freezing point of the solvent. And so a very, very good application of this is ice cream. And so the way that you make ice cream, you would need to have salt. And so the salt will be the solute that will then cause a freezing point depression. And so the ice cream actually is able to form below normal freezing point of water, which is 0 degrees Celsius. And so that is why it can be made. So a very tasty application of the freezing point depression. All right. Finally, we have osmosis. If you remember from biology, osmosis is when you have a higher concentration of particles that will then go down to a lower concentration of particles. And so, again, if you think about the hill analogy, it's a lot easier to roll high up to down a hill than the other direction. So it goes from a higher concentration to a lower concentration. The pictures here show a concentrated solution on the left, the dilute solution on the right. These are separated by a semi-permeable membrane. If we're to zoom in on this, we would see that the smaller particles are able to get through the membrane. The larger particles, because of the size of the pores of the membrane, will basically be kept out. And so over time, you will see that more of the small particles will then get into this other arm, and therefore you will see a change in the solvent concentration. And so in this case, we're looking at pressure, and for osmotic pressure, they use the Greek symbol pi because it stands for P in the Greek alphabet. So the net movement of solvent from the area of a high solvent concentration to the area of a low solvent concentration, and so this is referred to as osmotic pressure as well. All right. And so we are now finished with our discussion on solutions, and so next time we will go over the study guide, and then you guys will be then ready to take the test. And so I hope you guys have a good rest of your day, and I will talk with you again soon.